In this situation, we have that a computer virus nicknamed the Sapphire Worm spreads throughout the internet on January 25th, 2003. See the figure. The population of infected computers is modeled exponentially by P of t equals P sub 0 times e to the kt, where k is greater than 0. Studies suggest that during the first few minutes, the population of infected computer hosts increased exponentially with growth constant k, which is equal to 0.0814 s to the negative 1, so 1 over s. What was the doubling time of the virus? All right, there's a lot going on here. But what we are going to do is to work with this particular model. So this is a model that says that P of t is equal to P sub 0 times e to the kt. So we're working here with the natural base e. Remember that e is the natural base, which is approximately 2.71, that irrational number. But I'm going to keep it as e. It's going to be cleaner that way. Now, we have to figure out what is the value of P sub 0 and the value of k. T is the independent variable. T is like x, so t stays in the model. Now, I have both of these variables, P sub 0 and k. K was explicitly given to me right here. And then P sub 0 is the initial value. The initial population, that is P sub 0. Because if t is equal to 0, then all of this, e to the kt, becomes 1. Again, if t is equal to 0, e to the kt becomes 1, and you're left with P sub 0. And P sub 0 will be the value of the population at t equals 0. For that, we're going to use the graph. If you notice here, they gave us a graph. And when t is equal to 0, look, right here, the population is 4 when t is equal to 0. So then that means that the model is now equal to 4 P sub 0 times e to the k, the growth constant, which is 0.0814 t. There is my model. Actually, this was quite simple to obtain. So now that I have the model, I think I can answer the question. What was the doubling time of the virus? When they say the doubling time, they mean what is the value of t, or how long does it take for the population to double from what it was initially? How long will it take to the population to double the amount of what it was initially? So initially, the amount was 4. How long will it take to go to 8? 2 times 4, 8. So we're going to set the population equal to 8 for e to the 0.0814 t, and we're going to set that entire population will be set to 8. And now we're going to solve for t. That's it. So we're going to go ahead and divide both sides by 4. 4 will divide out on the left, and we're going to have e to the 0.0814 t equals to 2. Now, folks, I have to bring the exponent down. I'm going to take the log of both sides. Now, not everybody at this point is familiar with the natural logarithm. If you are, take the natural logarithm of both sides. Work with ln because you have the natural base. But if you're not familiar with the natural logarithm, if you haven't studied that yet, then just take the common logarithm, base 10. I'm going to go ahead and do the common logarithm, but you don't have to. You can take the natural log of both sides. So in this case, I'm going to have 0.0814t times the log of e equals to the log of 2. Whether you use log or natural logarithm, the answer will be the same. Then in this case, we will divide both sides by the log of e. And then on the left, log e will cancel out, and you're going to have 0.0814t equals to the log of 2 over the log e. And then as a final step will be to divide both sides by 0.0814, and over here the same, 0.0814. That will cancel on the left, and then we're going to have that t is equal to the log of 2 over the log of e, all that divided by 0.0814. You will now input all this into your calculator, and you're going to get that t is approximately 8.5 seconds. So it will take about 8.5 seconds for the population to double from what it was originally, for the population to go to 8.